boys and girls, it's Miss Bissell. We are starting lesson 4 in topic 1. We are on page 18 today, and today we're going to work with decimals, and we want to know how can we represent decimals. So when we talk about representing decimals, we're talking about different ways that we can show a decimal's value. So let's start with the solve and share on page 18. I'm sorry, not the solve and share, the visual learning, where we have Joe picked a seed from her flower. The seed has a mass of 245 thousandths of a gram. What are some different ways you can represent 245 thousandths? Now, our little fourth grade helper tells us that we could write the standard form. And if we review our vocabulary, our standard form means we're just using digits and symbols. We can use the expanded form. That's where we multiply a digit times its place value and add it to the next digit times its place value until we have the whole number represented. We could also use number name. Number name is like you would write it out in words for a spelling test. So these are 3 different ways that we could represent that decimal, 245 thousandths. So here is a place value chart. So if we look at the place value chart, we see that there's a place for the ones. We see there's a place for the tenths, hundredths, and thousandths. And think back to our lesson on Tuesday or Monday, I'm sorry, where we learned that numbers to the left have 10 times the value as the same number to the right. So tenths would be 10 times the value of hundredths, and hundredths would be 10 times the value of thousandths, and even ones would be 10 times the value of tenths. All right. We also learned then that the opposite is true. Digits to the right of a digit on its left would have 1/10 of its value. It would be smaller. So their thousandths would be a tenth of hundredths. Hundredths would have 1/10 of the value of tenths, and tenths would have 1/10 of the value of ones, just like we learned with whole numbers on Monday. All right, so let's look at the standard form first of all. 245 thousandths is how we would read it. The 5 is in the thousandths place. Its value is 5 thousandths. So we stop with the 5 in the thousandths place. We talked about this on our lesson 1-3. All right, expanded form. So this is where we're going to take the digit in the tenths place. That's our largest value digit. Its value is 1/10. All right. We're going to add it to the next digit, which is a 4 in the hundredths place, and hundredths are valued at 100th. And then we add it to the value of the 5, which is in the thousandths place, 1,000. And then the number name is just as I read it, 245,000. Now, let me show you something. Whoops. Hang on just a minute. Bear with me. Got a lot going on here at my desk. All right. Let me just show you one thing here. I also want you to recognize you don't have to write the decimals with the fractional form. Another way to write this number in expanded form would be to take the 2 and multiply it times 0.1. Isn't that how we would write 1/10? And we would add it to the 4, which is in the hundredths place. So that would be times 0.01. And we could add that to the 5, which is in the thousandths place, which we would write 0.001. So expanded form could be written with your decimal numbers shown multiplied by fractions or the decimal place values, okay? All right, so let's look at the convince me at the bottom of the page. And again, make sure you pause the video and have the examples filled out in your book. If you're not pausing the video and filling out the examples in your book, then you don't have what you need for the practice buddy, because honestly, you should have your assignment that we worked on together, pages 18 and 19 and 20, open when you do your practice buddy today. All right, so the question is, how many hundredths are in 1/10? How many thousandths are in 100th? Tell how you know. So let's start with the first thing. First question is, how many hundredths are in 1/10? All right, and I know that there are 10 hundredths in 1/10. All right. And I know that, let me write it first and then we'll talk about it. Sorry, I'm getting ahead of myself. There are 10 hundredths in 1/10. And I know that because the hundredths are to the left, sorry, the tenths are to the left of the hundredths, right? So if I have 1/10, then I know that it takes 10 of the little hundredths to make up one of the 10, right? So this right here would be 10 hundredths equal 1/10. All right, I'm probably not doing a good time explaining this. I'm going to have to go back on this one. I apologize. All right, the next question was, how many thousandths are in 100? So there are going to be 10 thousandths in 100. So in 100, I know that I need 10 of the thousandths to make 100. They're smaller, so it takes 10 of those. So there are going to be 10 thousandths in 100. All right, and thinking about place value and how they're related and going back to our assignments that we did on Monday would help with this, Monday's concept. All right, so if I write 1/10, 10 hundredths, sorry, that was the first one. If I write 10 hundredths, it looks like this, right? And 10 hundredths then equals 1/10, right? We talked about that here, okay? And then when we talked about there being 10 thousandths in 100, then what I know is that 10 thousandths equals 100, okay? All right, give you a second to write that down. All right, we're going to come back to this, so don't worry if that's still a little bit foggy. We're just starting with today's lesson. All right, so we're going to be talking about equivalent decimals, and this is an important vocabulary word, so it is highlighted. So equivalent decimals name the same amount. What are two decimals equivalent to 1 4/10? So the fifth grade helper tells us that 100 is equal to 10 thousandths. So what are two other decimals equivalent to 1 4/10? 1 4/10 is the same as 1 40 hundredths. So we could take the 1 whole, and 4 of the rods would be equivalent to 40 of the little squares. And don't forget, we talked about the rods being tenths, and we talked about the little square being hundredths, because it takes, in 1 whole, we have 10 of the rods, or we have 100 of the little squares, okay? So thinking back, I believe that was on Tuesday's lesson, all right, on lesson 1-3. So I know that 1 4/10 is the same as 1 40 hundredths, and I can see it here, all right? 1 4/10 is the same as 1 400 thousandths, all right? Now, 400 thousandths, if you remember, to make a thousandth, we take one of these little hundredths, we break it into 10 equal parts, and that would give us thousandths. You can see it right here kind of magnified. That is hard for me to even imagine because that is such a little amount, all right? But that would be taking this 1 whole and breaking it into 1,000 equal groups. So 4/10, 1 4/10 is also equal to 1 400 thousandths. So when we look at the whole thing, I see that 1 4/10 equals 1 40 hundredths, and that equals the same as 1 400 of the thousandths. Now, this is important. Put a little cloud around it. I want you to notice something. If you take zeros off of the 40 hundredths and the 400 thousandths. Don't you still have 1 and 4 tenths? Now, you guys had started some decimal work last year, I think, when we got out for the COVID emergency situation. So I'm thinking that Mrs. Holt probably got around to talking about decimals a little bit, but equivalent decimals name the same amount. All right, so let's continue and see how we do with the rest of this. The number 3 and 453 thousandths has two threes. All right, I see a 3 in the ones place and I see a 3 in the thousandths place. Why does each 3 have a different value? So let's talk about the first 3. The first 3 we just said is in the ones place. So that's going to make its value 3 ones, right? Or 3. All right, the second, let's do a comma here. The second 3 is in the tenths, hundredths, thousandths place. All right, so that gives its value as 3 thousandths. Wow, that is a little itty bitty amount, isn't it? Much, much smaller than one whole. Okay, so remember with the place value system, digits have an assigned value based on where they are in the place value chart. All right, in questions 2 and 3, we're going to write these numbers in standard form. So standard form is where we just use digits and possibly commas or decimal points. So I'm going to show you a little trick, and actually this reminds me of number 4 of your weekly review this week. And number 4, you're actually taking a number like this from expanded form and writing it in standard form. So hopefully this will help. I noticed that my largest value is 4 times 100. And 100 has 3 digits in it. So let's do 3 blanks for the 3 digits. I notice I'm going to have some decimal numbers, and I know that because I see I'm multiplying some digits times 1/10, 100th, and 1,000th. So I'm going to do my decimal point here. And since my smallest value is thousandths, I know that it's going to have 3 digits behind the decimal point. This is going to help you write your number correctly, especially when there are zeros that we need to include in the number. We talked about this the other day in class. So we're setting up a little template here. So the first thing I see is I have 4 times 100. So the 100 is the hundreds place. So ones, tens, hundreds. I'm going to place my 4 in the hundreds place. Next, I'm going to add the value of 7 times 10. The tens place is here. Remember, ones, tens, and I'm going to put a 7 there. All right, I'm going to add it to 6 times 1. The ones place is right here, and I have 6 ones. All right, now I'm getting into that decimal place value. 6 times 1/10. That means I have 6 tenths, and those 6 tenths will be right here. Tenths, hundredths, thousandths. All right, this is 3 times 100, so that is 3 hundredths. So my 3 is going on this line. And last, I have 7 thousandths, and the thousandths will be located 3 digits behind the decimal point, and the 7 goes right here in the thousandths place. So in standard form, this is 476 and 637 thousandths. All right, now I'm going to take this and write it in standard form from a word form, or what we might call number name or written form. So when I see the word and, I want you guys to know that that is indicative of a decimal point. We say the decimal point, we say and when we see a decimal point. The only exception would be if we had a number like this, where 0 is the whole number, and then we just read that as 25 hundredths. But this is going to be read 4 and 68 thousandths, and I know 4 would go in front of the decimal point, so that's 4 and for 68 thousandths, I know that thousandths needs to be 3 places behind the decimal point, so the 8 needs to end up in the third place value slot behind the decimal point. So the 8 would go here, the 6 would go on the 10th, so I have 68. So remember, we need to fill in the 0 here. So 4.068. And I can leave the blank lines or not, but this is what it looks like in standard form. All right, let's do a couple. If you want to pause the video and try a couple based on what we did on numbers 2 and 3, you can do that. All right, this number right here, 2 times the 1, which is the ones place, and added to 6 times 1,000. So I know that between the ones and the thousandths place, I'm going to need to have a decimal point. So 2 times 1 means I have a 2 in the ones place. I don't have any tenths, hundredths, and here would be my thousandths. So 6 times 1,000th means 6 thousandths would go here, and I'm going to plug in my tenths and my hundredths with 0. And this number in standard form would be 2 and 6 thousandths. All right, let's try another one. So I see here that I have my largest value is in the ones place, so I just need my 1 blank here. My decimal point, because I'm moving over to tenths and then thousandths. So thousandths would be 3 digits behind the decimal point. So let's just set up our little template, I like to call it. All right, and now let's fill in our values. So 3 times 1 is 3, so we have 3 ones. 3 times 1/10 would be 3 tenths. So in our tenths place, we have a 3. 9 times 1,000th would be 9 thousandths, and that's going to go 3 places behind the decimal. So boys and girls, I'm going to need to fill in a 0 right here. And if I hadn't used my template and looked at my highest value number of digits and noticed that this is the thousandths 3 digits behind, I might forget that 0, and I might have written that incorrectly. So this number in expanded form is written as 3 and 309 thousandths in in standard form. All right, word form, 9 and 20 hundredths. Don't forget, and is indicative of our decimal point. 9 would be my whole number. 20 hundredths, that means I need 2 digits behind the decimal. 20 hundredths. So 2 tenths, 0 hundredths make 20 hundredths. I want to stop in the hundredths place with the 20. 9 and 20 hundredths. All right, now we're going to go back to what we were doing at the top of the page that I said may be a little difficult, and we're going to see how we understand it. And we're going to write 2 decimals that are equivalent to the decimal given. So I noticed that we have 2 and 200 thousandths. So if I just took off 1 0, 20 hundredths would be equivalent to 200 thousandths. So I could write it as 2 and 20 hundredths. And that's going to also be equal. Couldn't I take both zeros off? And 2 and 2 tenths could also be equivalent. All right. 8 and 1/10. I want to write 2 equivalent decimals. So I'm thinking, why don't I just add a 0 and make it 8 and 10 hundredths? 1/10 would be the same as 10 hundredths. Think about it. That 1 rod and 10 of your little squares would be the same. All right. And one more equivalent decimal. I know thousandths, so why don't I just add another 0 and make it 8 and 100 thousandths? When I take those zeros off, I get back to my original 8 and 1/10. All right. So let's check this one out. This one is 9 and 50 hundredths. So I'm thinking for one of my equivalent decimals, couldn't I take off a 0 and have 9 and 5/10? 5/10 is the same as 50 hundredths. And then I could add a 0 to 9 and 50 hundredths and make it 9 and 500 thousandths. If I took off the zeros at the end of my decimals, they would all come back to 9 and 5/10, wouldn't they? That's just a little visual trick if that helps you, if you're a visual learner. All right, number 10, we're going to write 2 equivalent decimals for 4 and 200 thousandths. I'm just thinking about treating this like we did number 7. Why don't we take off 1 0 and have an equivalent decimal be 4 and 20 hundredths? And then if we take off the other decimal, we have 4 and 2 tenths. So again, if we took the zeros off at the back of each decimal, everything backs up to being 4 and 2 tenths. You can see it that way. Otherwise, we can pull out the base 10 blocks and look at it. All right, if you need to stop my video for a minute and get caught up on any of these, go ahead and do that. Make sure you're using the blanks, the template that we talked about. All right, and we're going to answer a couple questions on the back, and then we're going to wrap up today's lesson. So let's look at a word problem that would use today's concepts. Santiago has a rope that measures 205 and 95 hundredths of a centimeter. Write this number in expanded form. All right, so the first thing I notice is I have a 2 in the hundreds place. So wouldn't that be 2 times 100? I always write the digit first, by the way. I always write the digit that's there. Then I'm going to add it to my next number, but it's a 0, so I don't have to include it. I go over to the 5. The 5 is in the ones place, so that would be represented as 5 times 1. Then I'm going to add it to the 9, which is in the tenths place. So let's put in parentheses 9 times 1/10. Okay? And then we move over. The 5 is in the hundredths place, so we're going to add to this the 5, which would be times 100. Okay? So you could, if you want to, put the parentheses around all of your little multiplication expressions. I do it like that when I'm writing. It just helps me see each digit better. All right, we don't need a 0 times 10 because if there is a 0 in our number, we don't need to represent it in expanded form. Okay? Now, our next question, how can you tell that 7 and 630 thousandths and 7 and 63 hundredths are equivalent or equal decimals? All right, so what I notice about them, the 7 is the same in the ones place, the 6 is the same in the tenths place, the 3 is the same in the hundredths place. So the 0 in this thousandths place doesn't add any value to the number. So if you want to do a place value by place value comparison, you might think of it that way. Another way to think of it is if you take off the 0, don't you have the same number, 7.63. All right, so I'm going to just make a note here that the 7, the 6, and the 3 are in the same place, meaning the same place value position in both numbers. Okay, we just talked about it. 7 ones, 6 tenths, 3 hundredths. All right, the 0 in the thousandths place adds no value to that number. Okay, so maybe you could think of the equivalent decimals in that way. All right, if you need to pause me, you can, so you can get that written down. All right, I want to talk about one more problem. Number 14, in Justin's school, 825 thousandths of the students participate in a sport. If there are 1,000 students in Justin's school, how many participate in a sport? All right, so let's think about that a minute. There are how many students? 825 thousandths. All right, so isn't that 825 students out of 1,000? Let's write that as a fraction. 825 out of 1,000 is how we would represent 825 thousandths. And then they just kind of told us what we already know. Since it's 825 thousandths, we know there's 1,000 students in the school. So now let's think about the parts of your fraction. The numerator names how many we're talking about, and the denominator names out of how many equal parts. So aren't we talking about 825 students out of 1,000 students that are participating in a sport? So what that tells me is that 825 students, the numerator answers this for me, 825 out of those 1,000 students participate in a sport. Okay, so 825 students participate in a sport. All right, so let's go back. How can we represent decimals? So we looked at a couple ways. We looked at standard form, which is just your digits and your commas or decimal points. We looked at expanded form and number name. The other thing we looked at were equivalent decimals. So again, you should have everything filled out on pages 18 through 20 that I have filled out. And you should have this on your desk while you're working with your practice buddy for lesson 1-4. All right, boys and girls, I hope you have a great day.